Okay, hi guys. So in this lecture we'll be talking about stereo centers. So let me write down the heading first. Stereo centers. Okay. So let us take an example for the same for understanding the stereo centers. So this is one of the compounds that is possible across the pi bond, and another is you know it can be this is cis butene and another can be trans butene. So these are showing geometrical isomerism. So so stereo center is uh, so you can say that stereo center is formed at the double bond. So because by interchanging one pair of group across um, atom or a group or a pi bond, if we get different stereoisomer, which is this, then it is known as stereocenter. Okay, so 2-butene has two stereocenters. A beg your pardon, has two stereocenters, and which are this carbon and this carbon, and the isomerism would be shown across the pi bond. Okay, so let me write down it more formally. That okay, let me write it down here only. So by interchanging one pair of group across atom, if we get another stereoisomer, then it is known as stereocenter. Okay, so in this case this implies that if we have a structure like this with a double bond and CC attached, so this is a stereocenter and this is a stereocenter and stereocenter. Okay, so stereoisomers is a combination of geometrical isomers and optical isomers. So when in any question, if it comes that you have to calculate total number of stereoisomers for the given compound, then you have to include both geometrical isomers as well as optical isomers. So please remember this. Don't just calculate only geometrical, or don't just calculate only optical. You have to calculate both. Okay, so let us look at some more examples. We have this compound I and Br. Okay, and let's say we also have a mirror image of this compound as Cl, Br, I and F. Okay, so how many chiral centers are there in this compound? Obviously chiral center is 1. And how many stereocenters are there in this compound? It is also, the answer remains the same, because in this case the chiral center is the only stereocenter. Okay, let us take more examples. So if we have something like this and CS3, so in this case how many chiral centers are there and how many stereocenters are there? So the number of chiral centers are only 1, and the number of stereocenters are this one, and this one. So number of stereocenters are 3. Okay, so for this compound, let us calculate number of chiral centers and stereocenters. How many chiral centers are there? Don't forget a lone pair on both the nitrogen atoms. So number of chiral centers in this compound is 0. Why? Because both the nitrogen atoms are sp2 hybridized, and number of stereocenters are obviously 2. This one and this one. Okay, let's calculate the two values for this compound. We have cyclohexane ring substituted with two CS3 groups on adjacent carbon. So how many stereo chiral centers are there? This one and this one, 2, and stereocenters are also 2. Okay, let us calculate for this ring, cyclobutane ring substituted with HBr and HBr here also. How many chiral centers are there? So okay, so let this be Cl. Okay, so chiral centers are 1 and 2, and stereocenters are, okay, so is there any chiral center here? There is no chiral center in this compound. Why? Because on this carbon atom, if you go by this ring, from this carbon and from this carbon, or in other words clockwise or anti-clockwise, you will encounter the same group. You will end up at this carbon atom, which either you reach from clockwise or anti-clockwise, it is the same group. So number of chiral centers for this compound is 0, right? Because the groups attached to this carbon atom are not distinct. Similarly, for this sp3 hybridized carbon, the groups attached are not distinct, and hence the chiral center is 0, but stereocenter is 2. Why? Because it can easily show geometrical isomerism across, because of the ring, right? And on the ring we have these two carbon atoms which will be showing geometrical isomerism. Why? Because Cl and Br can change their positions. They can either be on the upper side and can replace H, and H can be on the lower side where Cl is presently there. Okay, so this is a good example for revision purposes. Okay, so let's calculate for this thing. So here we have OH, here we have OH. Okay, let us calculate the stereo chiral centers. This is a chiral center, this is a chiral center. Oh, I beg your pardon. This is the chiral center and this is the chiral center. Number of chiral centers are 2, and number of stereocenters are number of chiral centers, which is 2 plus this, and this. So 2 plus 4 is 6. So with this we come to an end of this lecture, and from the next lecture we'll be saying diastereomers. So till then, good luck and goodbye. And again, just a note that just keep revising your concepts of organic chemistry again and again by watching the videos again and again, so that you become confident and very clear about all your concepts. And I want all of you guys to have a very strong fundamental basis of organic chemistry, so that you perform your level best in your examination. Okay, good luck.